I'm all set.
I'm also all set. Ooh, UPS has arrived. Welcome to the Hackaday podcast. My name is Mike Stish. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 105. Today we're talking about 486 Doom running on an FPGA. How thick is your filament? A Raspberry Pi that speaks Android Auto. And we're headed to Mars. Elliot, did you hear about this water treatment plant in Oldsmar, Florida?
Yeah, I did. This is not cool.
Not cool at all. So the reporting on this is that someone accessed the water treatment plant process system remotely and upped the, what was it, sodium hydroxide mix from its normal 100 parts per million to 11,100 parts per million. Now, the good news is someone at the plant was watching when this happened, saw the settings get changed remotely. And so they were able to reset them immediately. And the organization has come out and said, it takes 24 to 36 hours for the water to actually go out into the system once a change like this has been made. And there's a bunch of redundancies along the way that would have caught it. But it's more like looking at public infrastructure that's available remotely is a little scary.
I mean, do we know who did it yet? Do we know if it's disgruntled former employee who has credentials, or
that was
system's just totally loose? Or...
Yeah, if you're going to spitball, no, I don't think that we know yet anybody. But if I was going to guess, I mean, you would think it was someone that knew the system, right? So that would point to disgruntled employee. But who knows? I mean, it's pure speculation. Well, do you think there should be air-gapped systems on a water treatment plant? Or should the process engineers be able to log in remotely and see how the system's doing?
Yeah, I went back and forth on this a couple times in my mind, actually. At first, I was like, there's no reason this should ever be connected to the internet. And then I'm like, well, especially when everybody is stuck working remotely, maybe it isn't such a bad idea. I mean, it clearly should be securely locked down and access should be very difficult. This is the sort of thing that I would think that physical access wouldn't be a bad thing to require.
Yeah, maybe read-only access is the kind of remote access that you have.
Yeah, but when you're just randomly poking around the internet and you find one of the controls is this is the control rods. Don't press lift them all out, okay? Just do us all a favor. Thanks.
Well, let's do some happier news since we've done our doom and gloom. KiCad 6 is in the works and should be with us later this year.
Yoo-hoo!
Kerry Scharfglass wrote a nice roundup of this. I'm glad he gave me a warning about how big the new feature article by Peter Dalmaris is, because when you go and look at it, it is quite substantive. But there's some exciting stuff in there. I mean, crosshatch fill now, which I know a lot of people like. I haven't used that, but I think there's a good reason for it. Have you used it, Elliot?
Good reason is just because it looks cool. Since I etch myself, I don't use it much at all because it just eats up copper for no good reason. It does look snazzy.
Yeah, it has curved fillet, which is not the same as curved traces. I like it. It has proper grouping now.
Yeah, I think that's a big one.
Yeah, if you used KiCad before, you could always click and drag over a bunch of symbols, and that would allow you to move them as a group. But then as soon as you selected something else, it would ungroup them. And then you run into problems where you click and drag and you have a group and you move it somewhere, and then there are other components that are now where you would have clicked and dragged, and now you can't click and drag without screwing other stuff up. So I've run into that problem myself.
Yeah, that's a good one. When I was reading that, I almost thought it was finally the feature I've always wanted, which is to have footprint layouts available as kind of mini modules. Because I'll make the same power regulator setup. Here's the voltage regulator. Here's the capacitors. I have to lay this out every time. Why can't I just have that as a block? I can just copy paste from another project. That's on my feature list for KiCad 7.
To save it as a group footprint in a library that you could add a part.
Exactly.
Yeah,
just have a mini
that.
module, because half the design we do is kind of modular, right? It's this block, this block, this block. It'd be awesome if you could then just import this block in and do it.
Yeah, like I laid out a footprint for a switcher and, the inductor and other passives that go along with that. And like, according to the reference design on the data sheet, which had
Exactly.
the footprint and everything, and it's like, once you do that once, you don't want to do that again.
You should never have to do that again. I claim. KiCad 7. We'll put it on the feature list.
I think the one that's going to affect everyone here is it's kind of like a watershed for file formats. So like once you open your design up in KiCad 6, it's going to get reformatted into KiCad 6 format, and then it will not be opened up in KiCad, 5 or N-1 ever again. Interestingly, they show us side by side, and it's more human readable, which is nice, and it should be more accessible, they say, for like automated like Python shenanigans on the file level. But you open it up and it's Lisp reminiscent, because everything it's not like a JSON format. It's like everything's in parentheses and parentheses within parentheses.
Oh yeah.
So if you've always wanted to have Lisp Nouveau, check out KiCad 6. Well, I'm pretty excited about this first hack this week because it's a custom display that is recreating an old favorite, the Texas Instruments TIL 311. Remember that one, Elliot? I don't remember it either, but it's awesome. It's a dip chip that it has like a red transparent case to it, and then LEDs in a 7-segment display are present within that resin. A bunch of people in the comments talked about equipment or projects that they had that used these, and I think it was Bruce Perrins dropped in and said there's a bunch of ham radio transceivers that people are still using, the Yaisa FT301D, where these displays keep burning out, and people would love to get these replacements. In this case, Alex has been doing this project over on Hackaday.io, and I've been watching it for a couple of months, being really excited about it, but he didn't have it encased yet. It was always just like the bare board with the LEDs, but now over the last week has put up all the details on it. He actually used a STM8 microcontroller on a little piece of circuit board. He still hasn't totally figured out what he's doing for legs yet. I don't have the information, but I think he just stole the legs from like pin header, like a row of pin headers,
right,
and soldered them on. But the coolest thing, other than the way it looks and the fact that it just runs great, is he used the old part of vintage TIL 311 to make the silicone mold that he uses to pour the resin, and you couldn't have done it better. It looks just wonderful.
Yeah, it looks really great. Yeah, and doing the resin over the top really makes it work, right? That really makes it look convincingly like an old part. It's totally like that new old part vibe. I also love it because it's absolutely tiny. And Alex makes tiny LED matrices, and he's the master of tiny LED matrices. So it's nice to see him take on something like this. I hope it does enable some people to keep old equipment running.
Yeah, now I say do the bubble displays, because I don't think they're making those anymore. The HP had a part.
Yeah, right.
There was like a 4-digit bubble display. Let me see. I don't know if I can find the part number on that.
I don't know what the part number is either, but they're available cheap on eBay if you want to get some.
Oh yeah, I need to get some. I know I saw Dave Darko.
They're really fun to play with.
Yeah, he was doing a project where he had like a matrices made of those displays. So it was like almost like a terminal display, like 20 characters by 5 lines or something of these displays. And I was like, oh, that's so cool. It feels so wasteful because I don't think they're making them. I think they're surplus parts. I could be wrong about that. In these days of huge dots per inch, OLED cell phone screens, like these old vintage displays look great, and really superb job, Alex, on making this one yourself.
Well, speaking of cramming things into small spaces, Sylvain Munot has got Doom running on the ICE40 FPGA chips, and these are the ICE40 UP5Ks, which have, as the name suggests, 5,000 LUTs, 5,000 logic elements. That's a small, absolutely cheap, low-powered FPGA to have Doom up and running on. And his video explaining how he did it is just a crazy deep dive, both into kind of the old, 486DX computers, the old Intel computers that used to run Doom back in the day, then into the kind of RISC-V core soft computer system that he makes inside the FPGA to run it. Now, what he's not doing is cloning the original hardware in any way. He's just making a computer that has enough specs and everything else to run Doom. And that's what's really interesting about this, because he kind of just starts off by thinking about what you need to run Doom, right? Like, if you had a 486DX running 66 megahertz with 8 megs of RAM in 1994, you could run Doom. And he's like, well, let's see. I've got a RISC-V core running at 25 megahertz. That's a lot slower. But then he figures out that he's got a significantly more efficient multiplication, for instance, like integer multiplication. He writes this whole integer multiplication pipeline to make sure it runs in one cycle per multiply, whereas the 486 took like 13 to 40 or something. And so he's got a significantly more efficient processor emulated inside the FPGA. And then the rest of the video is just him going through kind of everything it takes to get a computer that's capable to run Doom up and running from scratch.
Yeah, I think the fascinating thing for me is the kind of back of the envelope measurements that he's doing in advance just to see if it's possible. And so comparing the speed of RAM on a 486 to the
Right.
speed of the external RAM chip that he's able to have, and being like, yeah, that'll probably work. And, starting to look at like the overhead of how caching worked in those systems. I mean, it's a tour de force in how to proof your concept, then how to actually execute on the design.
Yeah, and he looks to a couple other FPGA ports of Doom. These for the ECP5, which is a significantly bigger FPGA. That's the one we had in the Hackaday badge 2 years ago, actually. 2 people at least have ported Doom to that. And so he went and looked at their code and discovered that they had about, they were only using about 40% of the resources. So that was a good sign that maybe he could pull it off. And one of them, he even went and looked at what kind of tricks Ultra Embedded did to make Doom run on his ECP5 clone. And it's like, well, these are the problems I'm going to run into when I try to get it running on the UP5K. Just really great approach. And I actually had the opportunity to work with Sylvain on the Hackaday badge 2 years ago. I did the sound system for it, and then he came in at the last minute and was like, hey, I can make this a bazillion times more efficient. Would you like me to do that? And it was like literally the week before the conference. And I'm like, oh, I'm so scared. He really knows what he's doing. Let's go. And he just completely knocked it out of the park. So it was awesome.
Yeah, it was great having him on that crew. I think he was also the one who said, we should really go to a device firmware upload model for that badge. And that turned out to be a great improvement as well.
Great collaboration between him and Sprite. And that was just a good team all around making that work. I guess what I'm saying about Sylvain is he's got a lot of experience with FPGAs and packing the hard stuff into them. And so when he goes through a lot of this, he makes some of the things sound easy, like, oh yeah, just implementing the entire frame buffer and things like this.
Yeah.
That for normal humans would be a little bit more difficult. On the other hand, he really does explain all the different subsections fairly well. There's one final hack at the end that I really just love, which is the FPGA has a limited number of I/O pins, actually, and rather than dedicate them to a keyboard and mouse control to actually play the game, he runs it over serial from his main computer through Pygame. He's typing and WASDing and mousing around on his computer. Pygame is then shooting this over the serial line off to the FPGA, where all the rest of the gaming takes place.
It's Doom on a chip, but then you need a computer running Pygame to play it.
Yeah, it's Doom on a like $3 chip, but then you need to tether it to your laptop.
That's an excellent hack to get you to the finish line. I mean, he could have definitely built out those inputs another way. That was just the way that was available. Did you mention the RAM piggybacking?
So one of the things he needed here was to get 8 megs of RAM in there. And the board he was looking at, the Icebreaker, has a 4 meg RAM chip on it. And he uses this like super classic solution, which is to just take another SPI RAM chip and like literally solder it on top of the other one, except you flip up the select line. So you have the chip select line like dangling in the air and all the rest of it kind of piggybacked onto the RAM chip that's already on the board.
Yeah, it's just a DIP 8 package. So even that piggybacking is super simple hand soldering.
This is a trick I used back in the day to make a color computer 4K have 16K of memory. We actually did this. This was like going around the like computer club scene, right? Like you could add in extra chips just by putting them on there and flipping up the select line. And I'll be damned, he does that here to double his memory, which gets him more than enough RAM to run Doom.
Harris Andrianakis built himself a lathe, and this story is not about that. The lathe was powered by a sewing machine motor, and it came with kind of a weird motor controller. He wanted to add, more control over it, like either like some kind of ability to have an e-brake on the lathe, or maybe to do steps around. I'm not exactly sure all the things he was going for, but he managed in the process to let the magic smoke out of the board in a pretty grand way. This thing has 330 volts on it in order to drive the motor. And while it was hot, he plugged in an AVR in-system programmer to mess with the chip. And that was it. There is no isolation between the high voltage and low voltage sides on this board. I haven't experienced this yet, but from the way he's told his story, I don't think it's easy to realize that this is going to be a danger going into it. I think that it's something that can kind of catch people by surprise. And in the comments, several people commented on that and said, that's the point at which I ended up getting isolated supplies and, current limited sources on the workbench. Someone else also mentions, getting USB inline isolator so that you don't, zap your computer in doing this. Luckily, he didn't do that, but it did kill the microcontroller on the motor controller.
Yeah, he got super lucky that he didn't lose his computer on this one.
Well, the cool thing is he goes on to reverse engineer the different blocks of the design. And why does he do that? Because he's going to have to put a new microcontroller on there. He doesn't have the firmware for it. So you're going to have to write your own firmware. So it turns into an even bigger customization problem. He was hoping to add a few features, and now he's going to write the drivers for every part of the board from the ground up.
This is one of the reasons you want battery-powered gear. This is where if you have a battery-powered oscilloscope, you don't have to worry about what voltage the ground potential's at, or if you're running your laptop on its battery. Like a simple solution to this problem is to just unplug the laptop so that whatever the ground level is, it floats along with the device you've got there. Do not take my advice if you're working on line level circuitry. Yeah. Definitely get yourself an isolation transformer. Yeah, Elliot's unplug the laptop trick is janky, and it's going to fail because your laptop's plugged to a monitor and that monitor's plugged into the ground, or you'll mess up somehow. Don't do this. Don't do it. Don't do it. But in
what
principle,
we say on the podcast is not meant to be engineering advice.
Yeah, especially not anything to do with mains voltage. All right, my next hack this week is a video by Thomas Sandladerer. He is a 3D printing YouTuber extraordinaire. This week he's got a simple sensor makes filament measurement a snap. One of the problems that used to plague us back in the dark early days of 3D printing was that our filament was kind of irregular. But if the filament's fat or skinny, when you push it through the extruder, it's pushing more plastic through, and so you get blobs or you don't get blobs. And way back in 2014, Thomas started up on a project to build a filament thickness sensor so that he could compensate for this live in real time and just feed less when he has a thick blob of filament coming through and feed faster when he has a thin blob coming through. And he never got around to finishing this project until now, 2021, where he's got 3 of these nicely designed filament thickness measurement sensors, which we'll talk about in a minute. And unfortunately, / ironically, by now, the problem's gone away. All filament manufacturers are making filament for 3D printers, and to such great tolerances that all he can do with his filament sensors is measure and verify that, my God, they're all really nicely made.
This one's a really great use of that trick with the Hall effect sensor, and we keep seeing it time and again. We had a few episodes where we looked at flight control joysticks that people were building with 3D printing and Hall effect because you can get a good range of sense in it. I'm surprised here that looking at such a tiny bit of variation, you can actually get resolution on the sensors.
Now, wait. We haven't talked about how he built these sensors. And
Sorry.
no, that's spoiler, Hall effect sensor. They're really a neat design. He's basically got a little lever that is pressed down with a spring onto the filament as it rolls through a gap. That lever goes, up and down as the filament gets thicker and thinner and has a magnet on it, and that's connected to a Hall effect sensor. And when I first saw this, I'm like, ooh, that's a really clever design. That's going to be super nonlinear. How are you going to calibrate it? And his really cute trick there is he uses a bunch of drill bits so he can put in a different drill bit with a very accurate diameter and calibrate this thing out over his range there. Really like that trick. Anyway, he's open sourcing the filament thickness sensor. So if you want to make these yourself, you can go right ahead and just print them out. It's a couple bucks in parts. Really cute project.
This made me wonder about stability of sensors like that from environmental changes. So if it's winter or it's summer, are you going to have different readings coming in from the Hall effect sensor?
What would mess up a Hall effect sensor? Magnetic fields, right?
Well, I don't know what the mechanism in the Hall effect sensor is. Do you?
It's the Hall effect. So the Hall effect is you run current through a conductor one way, and if it has a magnetic field, you get a slight current 90 degrees to the main direction of flow. And that's the Hall effect. And that's what these are using to detect the presence or absence of a magnetic field.
Right, but they must be amplifying that signal internally, right?
Yeah, the sideways current is super, super tiny. And so they have to have a really high gain amplifier inside.
So that would make me think the temperature would affect it because you're going to amplify. So any small
just messing
change...
up the amplifier section. I guess it kind of doesn't matter for him in this case. I mean, the other thing that's nice about Thomas's videos, he's used to do huge cross-filament reviews where he tests how strong they are and makes up some really nice lab apparatus to do it. He does run 6-ish filaments through this tester and finds that although the manufacturers say they're good to tolerances of 50 microns, they're basically all within 20 and some even down to 10 micron consistency range. So you don't need a filament sensor to adjust for the filament, but it is nice to see that they're all doing what they say they're going to do. What's funny, though, is that they're not all exactly coming in at 1.75 plus or minus whatever. They're all coming in at different levels. They're just remaining remarkably consistent around their middle value. Unfortunately, this does mean you still have to measure out your new filament every time you get a new roll of filament. And that may be what these filament thickness sensors are good for, is some kind of automatic calibration routine for that. Although, honestly, how hard is it to just take a caliper to a roll of filament every time you get a new one, measure it in 5 different places, take an average, call it good enough? That's what I do. Oh yeah, where was I going with this? My point was that he measures 6 different filaments. They all have kind of 6 different baselines, but the only thing that's important here really for your print quality once you've measured that thickness is how consistent it is throughout the reel. So, if he does have some kind of temperature or alignment of the stars induced drift here, it won't matter for his results, which are showing that the filaments are consistent.
This next one really has my number, Elliot. It's another car infotainment system hack, and it goes, I don't know if you listened last week, but we talked about one that had a Linux running on a head unit of a Nissan Xter and got root on it. This is going the other route. So this is a vehicle that has a screen on it, but it's missing the smarts. So you can buy vehicles, or at least you could buy vehicles that had options for things like backup cameras or GPS units, but they would have to be installed as an option. And in this case, Luke Esselbruge's Volvo had a really cool screen that comes up like robotically out of the dashboard below the windshield and can show you like your backup camera. But he didn't have one of those and wanted to make it work with Android Auto. And so he moved heaven and earth, you might say, to figure out all of the things that you need to do to patch a Raspberry Pi into the system, show its composite video out on the screen, and at the same time ended up plumbing an aftermarket backup camera into the whole system, monitors it with an ESP32 to boot in order to make sure that you're not sucking 250 milliamps of standby power with that Pi board.
Yeah, I love this. This is just like, oh, your car has a computer in it? Pull that computer out, replace it with a Raspberry Pi, and now you have a computer that you can do something cool with.
You know, you're locked into whatever the manufacturer wants to do on that vehicle, and you can't upgrade the OS unless they push. You know, it's like the cell phone conundrum, where like you feel like you have a perfectly good piece of hardware, but time has marched on and the carrier stopped sending updates. You know, like there's a Android Auto for Ford Sync 3, but my vehicle stopped getting upgrades at Ford Sync 2. And so it's, you know, a low mileage vehicle that I can't hook up to, you know, modern technology. Plus, I don't have the backup camera or the GPS on it. So you have this touchscreen that plays music, and that's about
Right.
it. In this case, it is completely integrated into the system. You know, once Luke got it put in there, there's a connector that is made to control the thing. So it has a serial data port on it. And there's a second connector for the video that's coming in. And he actually uses a relay to switch between the two video sources before it goes into that connector, which is pretty cool. And so the ESP32 is able to listen on the CAN bus, figure out when you've put the thing into reverse. And when you do, it trips that relay so that you go from looking at the Raspberry Pi output to looking at the backup camera output. At the same time, the Pi is running an open version of Android Auto called Open Auto. So the ESP32 is listening for the steering wheel controls to come across the CAN bus and then sending those as commands to move Open Auto on the screen.
That is so cool.
And if you're not familiar with this, like the Android Auto is your Android phone plugged in via USB to the car. It's kind of like a pass-through and a GUI for a standard that's pretty well known from the phone itself. All the detection here, like the screen that goes up and down, it will go up when it detects you plug in your Android Auto phone, and it'll go back down automatically. And same with the backup camera, goes up and down from signals from the Pi.
All right, well, this is my last 3D printer hack of the day, I promise. This is Stefan from CNC Kitchen. 3D printer laser cutter CNC ? Yes, please. He got his hands on a Snapmaker 2.0, which is a combination 3D printer, laser cutter, and CNC. And he tries to be polite, and he finds that it can do a lot more than he thought it would. But again, it ends up being kind of a jack of all trades, master of none, I would say. I know this is like everyone's dream when they first build a CNC machine, 3D printer, or laser cutter, you know, with the XYZ gantry. You think, heck, that motion control will work for all three of these possible things. And one thing that Stefan does here is point out how some of the requirements for all of them are different, and where this one machine that kind of makes these compromises loses out on functionality in kind of each of the different realms. And I thought that was really nice. I've operated CNC mills before, and I've had tons of 3D printers. And 3D printers need to move a light head around fast and precisely. And CNC mills, if you're going to cut plywood or hardwood or metal or, they need to take a lot of side load and kind of push their way through stuff and have a really grunty motor on them to do the turning of the cutting blades and stuff like this. And so the requirements there of kind of the 3D printer's extreme agility and the CNC routers just brute force mill, go through things sideways, and stability. Anyway, they just have kind of different requirement sets. What is fun here, though, is to see how far he can go with one machine that tries to do all the different things. And I did think that was good. I think it's amazing that he got a 50-watt spindle to cut aluminum at all. like like I looked at the picture of this thing coming in, and it's a traditional 3D printer frame. It's got a really tall vertical Z, and you're looking at this spindle that's kind of mounted on this thing in a way that you can just tell it's going to pivot. And then it's got a really long cutting bit on the end of it too, which looks like it's going to snap off as soon as it hits the ground. He must have used really conservative speeds. But it does go to show you that a person who knows what they're doing with a CNC machine can make even something that's admittedly drastically underpowered like this get the job done. So, kudos to him.
I thought it was really interesting to hear the analysis that it doesn't have an emergency stop.
Yeah, right?
And I don't know if it was staged or if it was just footage from trying it out, but he shows you, starting out a cut, and then the bit is going right for a clamp, and it's going to break the bit because the computer doesn't care if the bit runs into something that it didn't know was there. It's just going to keep on turning those screws. And so his reaction is to try and grab the sled and muscle it to stop it from moving, which is exactly why you want an e-stop, so you can save your tools or save your material from cutting wrong or something like that. The interesting thing is the live control for this is an Android device that's tethered with a USB cable, and the screen doesn't even have the e-stop, and there is an e-stop add-on that's hardware apparently that's not even available. So that's a shocking fail for me on this, but I was pretty impressed with what it's able to do. I mean, if you look at it for what it is, which is a mid-cost desktop does-it-all machine, it seemed to do okay on that stuff. This is coming on the same week that we saw someone do a review of the Volterra printer's latest tricks. Do you remember that Volterra, Elliot?
Yeah, that's the circuit printer that prints out circuit traces using, I guess, low temperature melting alloy, right?
Yeah, well, conductive ink of some kind. And so the thing that they've, I haven't looked into that in a few years, and the things that they've added are the ability to drill holes, and so that you can use the rivet vias on them. And then there's also some pick and place ability and some reflow. It's on a hot plate. It's like a heated bed, but it's actually a hot plate for some type of reflow. Right. And I look at it and I'm like, well, why didn't they just make it able to mill boards at that point? And it's because it was never designed for that. So like you said, the forces, the lateral forces on a mill bit aren't going to work on the gantries for a 3D printer, which is what that was originally envisioned for. But I look at this and I'm like, this could mill the board for you. If this had those added tricks, it would be, I don't know if there's some way that you could do it. Really spitballing here, but if you could mill something like the other mill does with this, I don't know, the backlash might be too much on this one, but it's a thought. And then you add those pick and place and reflow abilities that the Volterra has, and you think maybe there is something there. Maybe you could have kind of like a press button, make a really simple prototype board.
I think this sort of thing's appealing to people who live in really small apartments because for the price of this thing, which was, I guess you got the deluxe version, which is like $1,800. And for $1,800, you get kind of a decent 3D printer and then kind of a crappy CNC mill and then, with a laser head stacked on it, right? And it's just a 455 nanometer blue diode laser. If you go looking in China for these sort of things, you can get a decent 3D printer for $350. You can get one of these cheap CNC mills for another $200. So you're out 500 and something bucks. You can pick up a 2-watt, 3.5-watt cheap laser diode for another $100 there. So you could kind of build this same functionality yourself for, a third of the price. But the trade-off there is then you've got at least 2 machines. And whether that's a good thing or a bad thing, I'm not really decided yet.
Well, but then you also have multiple tool chains for them, and you have multiple things that don't work well on different devices. I think there is something to be said for the unified tool and the unified tool chain. That the things that it does equally unwell throughout all the modes.
This is why I use the claw on the back of my hammer to open my beer bottles, because I want one tool to do everything. You see what I'm saying there?
I do see what you're saying there.
Yeah. Myself, I would rather have a decent CNC router slash mill to go along with my 3D printer and just admit that they're totally different machines.
First up on my list of quick hacks this week is building a continuously variable transmission with Lego. This is a project by Sariel's Bricks and Pets. It is a wonderful look inside of a transmission that I otherwise knew nothing about, even though my car has one and I know that they're often used on snowmobiles. In this case, you have two cone-shaped rollers and they're opposite, so that the big end of one cone is just across from the small end of the other cone. And a rubber band is connecting the two of them. So when the drive from the motor is turning one of the cones, the gear ratio is all set up on where among those cones that rubber band is transferring the power. It's a great example, and it shows you how you can build a little RC car that has speed control on it. Next is building a cheap Kubernetes cluster from old laptops. This is an interesting take on cluster building. We've seen people do it with PS3s and Raspberry Pis and just plain old computers, but I never thought of pulling out the boards, surplus boards from old laptops. They often have pretty powerful processors on them, and if you're looking to build up a cluster of your own, this is a great example to follow. Greg takes you through the process of designing some 3D printed parts, then make them all kind of nicely stored in a server rack and gets them up and running. Finally, I have an ESP will read your meter for you. This is Jomjal's project that takes an ESP cam module and focuses it on his water meter using a kind of 3D printed cowl and some lighting. You get a really high contrast photo, which is then used with some computer vision and AI on the edge, if I dare say that, in order to report back to a server what the meter is reading. I really like the concept, and Elliot, I have an order of these headed to me. It's somewhere between China and Wisconsin right now, and when they come, this might be my first project with them.
All right, my first quick hack is Majenko's reverse engineering USB protocols on a function generator. Majenko has a Windows-only Tenma 72-14.11.0. Majenko has a function generator, but it requires Windows software to run it. And so this is a project to reverse engineer its USB protocol that would display the image on the screen. This is one of those great demonstrations that reverse engineering is really just about knowing how the system should work and then kind of following your hunches. Majenko starts off by thinking, to get this much data across, it's got to be run length encoded. And then just looking at the data and noticing where it's the same all the time. Figuring out, if they have a limited color palette, they probably are storing the color information in there somewhere. Tweak some bits, see what happens. It's a great write-up and a great hack. I don't know if you have one of these, but you will learn something from the process. Next up, Ben Sato. When is Apple Beige not Apple Beige? Well, his Apple Beige is literally Apple Beige. He found himself an old jar of touch-up paint for the Apple II computers. I didn't even know they were painted, but apparently they were. Short spoiler for those of you with old Apples out there, Pantone 14-0105 is the code that you need. Along the way, I stumbled on some other retro computer paint jobs. Retro Hacks is producing Amiga 500 Beige, C64 Beige, and Atari ST/SE Gray. Who knew that there were so many different shades of beige? Last up, stay focused with this distraction-free cyberdeck. Konrad Barsky has made a really nice looking minimalist on-the-road computer/programming tool. It's got a nice long wide screen and a mechanical switch keyboard. None of these are cheap parts, but when you put them all together, it makes for an exquisite tool. Kudos to him for that one.
It's time for our can't miss articles of the week. This is excellent long form content written by Hackaday authors, and I've chosen one that Dan Maloney wrote. This is called Getting Ready for Mars, the 7 Minutes of Terror. I can't believe it's been enough time for that launch from last year, Elliot, to get to Mars.
Isn't that
But
crazy?
it,
It's
it
like it's
is.
just around the block or something.
I know. And, we just came off of the Super Bowl American style football. And to use the parlance, it's like the long bomb, right? So
Yeah,
with
right?
you have a quarterback that launches the ball down the field in hopes that the running back will catch up with it by the time it comes back down to be caught. So we have this package of this rover and other scientific equipment that we launch from Earth to a place. I think Dan says it in here that Mars, we hope Mars will be there once this gets there. So the planet has to catch up with this. So even beyond just the orbital mechanics of how we can manage to do that, this landing is going to be incredible. And I'm definitely going to be watching it. Coverage is scheduled to begin on the NASA YouTube channel on the 18th, which is next week on Thursday at about 11:15 a.m. Pacific time. I actually saw the 7 Minutes of Terror presentation at Maker Faire Rome in 2019. Alejandro Miguel San Martin was there from the Jet Propulsion Labs giving this talk, and I was totally unaware of the immensity of the project that got Curiosity to land on Mars. It starts with the aircraft itself going down into the atmosphere. There's a huge parachute involved, and like the forces that go on with that are incredible. You think about how thin the Martian atmosphere is, the
Right.
parachutes are a lot less effective. And then the parachute lets go and the pod starts falling again. And then it's like an octocopter, except for its jets of hydrazine instead of propellers kind of fly this thing around and slow it down. And eventually they lower by cable the lander, the rover itself, to the ground, at which point explosive bolts cut those cables and this jet powered octocopter flies off and lands elsewhere.
Yeah, this is the part that's just mind blowing on the sky crane maneuver. The idea, I guess, is that Perseverance is going down there to look for signs of life or whatever, and so they want to keep the spot where it lands as uncontaminated as possible. And that means no landing rocket engines there. And so they're going to hover this thing and slowly drop it down like Mission Impossible style on these cables and then pop the cables, and then the top parts just go fly away and crash land somewhere else. That is just so crazy cool. And the fact that they're doing this remotely on another planet is like a million times cooler, of course. But this would be difficult to do if you could monitor it up close and it were happening, back on a landing pad here on Earth somewhere, right, Elon? Like, this is hard enough to do when you have instant feedback, but now imagine you have a whatever 18-minute loop between your communications with the device and any responses. I mean, it's all got to run autonomously. It all has to work. And whew, I see what they mean by 7 minutes of terror.
Well, and like the cold storage aspect of this, they launched the thing 7 months ago and it's been going through very cold interstellar space. And then, there's no one that can like wake the thing up, right? It's all on its own systems. I'm sure there are checks that they do to
Yeah,
make
yeah.
sure everything's running. But, to think about packaging something up for 7 months, subject it to extreme cold, and then put it into a situation where any kind of failure could easily be catastrophic is bonkers.
Yeah, it is high risk to be sure, but
And it totally worked last time. So I really hope that it totally works this time. And if it does, it'll be a huge accomplishment. Like you said, they are going for a much smaller landing area this time because they're going at what they think is the output of like a delta formation from a river that is no more. Because on Earth, that would be a place of very concentrated life forms. So if you're looking for signs of life from Mars past, this would be a good place to do it. One of the interesting things that I didn't realize is they have a landing system now that uses a downward pointed camera and does like computer vision sorts of things to try and make sure that it's flying to the pre-designated landing zone. Whereas before they kind of had a larger area and they're like, well, it's going to land somewhere in there because they didn't have that course correction during reentry.
right. And they're trying to hit something to within about 40 meters, quote, while avoiding any large obstacles. Oh, dude. High stakes, high budget, real, honest to goodness space science. I love it.
Well, Elliot, you have had hardware on your bench again this week. What did you bring us with one of your wonderful articles?
Yeah, back here on Earth, I had a look at the new ESP32C3 chip. And despite the name, this is set up to be basically the competitor for the ESP8266. It's got a single core like the 8266. It's got only a few more GPIO pins than the 8266, but it earns its ESP32 name by having a lot of the peripheral set. The other thing that's really neat about this new chip is that it has a RISC-V core inside of it. And so it runs a little bit more efficiently than the Tensilica cores, but it also runs on this entire open ecosystem where the ISA, the instruction set architecture, which basically boils down to kind of the machine language of the RISC-V chips, is a standard. And so it's very easy to write compilers for this that will optimize for this, or we just saw a RISC-V core emulated in an FPGA. You can use the same compiler for all of these because it's like they were the same chip inside. So that's really cool. But in the end of the day, I think what was surprising about this was how little difference there was to switch up from compiling for the ESP32, which had these twin Tensilica cores in it, and then compiling for the ESP32-C3, which I'm just going to call the C3 from now on, which has this RISC-V. It really, from the user standpoint, made no difference whatsoever. It was just, one compiler flag and everything switches over.
So it looks from the timing diagrams that you put on here that the RISC-V core performs better than the Tensilica core.
Per megahertz, it runs faster and more efficiently than one of the Tensilica cores. The two cores in the ESP32 both max out at, I guess, 240 megahertz instead of 160 like the C3 does. So when they're both clocked at 160, the C3 is running faster. But the ESP32 has two of them, and they're both chugging along at 240. So this isn't going to be an ESP32 competitor when you really need that processing power and stuff like that. But it's definitely a bit of a processing bump up from the ESP8266.
I was really happy that Sprite reached out to us, and these are actually engineering samples. So these are pre-production run samples, and got them to you, which I thought was really cool. I did see he dropped into the comments right away and mentioned that they are hoping that they're going to have a JTAG port that doesn't take up I/O pins.
Yeah, they want to sneak that out the USB. I think that's gonna be cool, actually, if they can do it. They've got a couple more features here that may or may not make it into production, so I didn't write about in the story, but we're gossiping, right?
Oh, of course.
They may have a USB peripheral on this thing. There was a bug early on, and it didn't make it functionally onto these pre-production chips, but if they can hammer that out before production, these may be USB enabled, which would be a really interesting capability for the chips, meaning you don't need a USB to serial converter chip on there anymore, for instance. I don't know. I guess for me, the big story here is that it's going to be priced like the ESP8266. So it's going to be half the price, let's say, of an ESP32. But it's got a lot of the really cool ESP32 peripherals, including their crazy IR RMT system, the remote control subsystem, which lets you put out data in really fun ways. It's got the I2S peripheral. It's got the fun LED-C, which is their PWM/LED controller solution, which lets you put out, in the case of the C3, 6 independent PWM channels with incredible resolution. It really is like an ESP8266 competitor in terms of kind of price and speed. But then in terms of peripherals, you just get the whole bouquet of ESP32 peripherals with it.
And that is really powerful. Like you mentioned, the ability to just change basically a define line in your file and then compile for the other architecture.
Oh, dude. Yeah, one of the other things that's interesting about this, I also did some tests on integer and floating point math. And at least in my results, the ESP32C3 was faster in both integer and floating point than either of the ESP32 or the 8266. So I do think there's a little more going on here under the hood than just saying the RISC-V and Tensilica cores are equivalent. I do think that either compiler tricks or just the RISC-V core is slightly faster, slightly more efficient. I do think there's a definite win going on here from having that core in the new chip. So, oh yeah, and before we go, the one really cool thing about the C3 is that it's got about 400K of RAM on board compared to the 8266, which ends up, after you take care of Wi-Fi and stuff, having about 40K of RAM. This one has about 400. So order of magnitude more RAM on board on the new chip, which is going to make it really nice for running things like MicroPython or doing anything that's memory heavy. So I think it's just a lot more versatile chip. If they can come in at the ESP8266 price point, which is darn cheap, and they're able to pull that off with more memory and more peripherals, and if that's all due to the RISC-V core, that's a win too.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment in the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, please let us know about it. tips@hackaday.com. And until next time,
keep on hacking.
Do you hear that? Who let my dogs bark?
I don't know what's wrong. I'm actually freezing up here. What is this thing called? I should have looked at the name of it.
50 Shades of Beige sounds like a good YouTube channel you should start. 105?
105.
Maybe. Possibly.
Elon Musk.
Go read it.
Not our job. Here's the article, kid.